The rate at which we're advancing computing is insane. Over the course of the last 8 years, we've increased computation by 1,000 times. Look at this. This is Grace Hopper. This is Hopper. Hopper changed the world.
Nvidia's new superchip has just shaken the tech world. This groundbreaking chip enables AI to operate independently, seemingly bending the laws of physics in seconds. It is thousands of times more powerful than anything we've seen before, offering massive cost savings and effortlessly solving complex problems. Its arrival has shocked the entire industry. With 28 billion transistors, it moves data at lightning speed and shatters all previous limits. What happens when technology surpasses our wildest dreams? Join us as we reveal how Nvidia's new superchip is set to revolutionize the industry and defy reality itself. The biggest revolution in AI. Nvidia's earlier model, the Hopper chip, marked a significant step up in technology. It was packed with thousands upon thousands of tiny components called transistors, totaling in the many billions, which made it extremely efficient. The design of the Hopper was particularly smart, featuring a double-part structure that allowed the parts to work together flawlessly. This setup enabled the chip to transfer data at a staggering rate of 10 terabytes per second, solving problems such as inefficient data movement and insufficient storage that previous chips couldn't handle. Faced with challenges that seemed too hard to overcome, Nvidia's engineers thought outside the box and surpassed these obstacles with the creation of the Blackwell chip. Designed to adapt well with different system settings, this new chip showcases Nvidia's ongoing efforts to meet and conquer technological challenges. As technology progresses rapidly, the industry has turned into a fiercely competitive race. Companies are constantly pushing to unveil the next innovative product, driven not just by practical needs, but also by the thrill of exploring what technology can accomplish. This relentless drive for the latest advancements forces companies to frequently update their systems, often replacing old technology with new gadgets before the former is fully utilized. These fast-paced changes not only involve hefty expenditures, but also present significant environmental challenges. This swift evolution prompts a reflection on our relationship with technology. Are we controlling it, or is it beginning to control us? With the speed at which new technologies are developed, it is essential to strike a thoughtful balance. This balance should not only embrace the introduction of new technologies, but also consider maintaining sustainable practices. We need to carefully evaluate the advantages of the latest tech against their broader impacts on society, which is increasingly influenced by technological progress. Moreover, as we integrate new technologies into our lives and workplaces, we must consider their long-term effects on our environment and overall well-being. It's crucial to develop and adopt technologies that not only enhance our capabilities, but are also safe and sustainable for future generations. The ongoing dialogue about technological growth is vital, as it helps us understand the importance of managing our technological landscape responsibly and thoughtfully, ensuring that we use technology in ways that enrich rather than complicate our lives. This ongoing discussion underscores why we must be vigilant and proactive in how we adopt and manage new technologies, aiming for progress that is both innovative and responsible. Looking at further developments, the second version of the Hopper chip quickly went from a prototype to a working product, with some versions being extremely expensive, costing billions. Although future versions are hinted to be more cost-effective, they come with environmental and financial concerns. The newest design incorporates 2 Blackwell chips and 4 dies, connected to a Grace Hopper CPU, renowned for its rapid communication capabilities, all compacted into a small setup. Nvidia suggests that future developments might push beyond what we currently believe is possible with their new transformer engine, leading us into an era of more sophisticated systems. This latest improvement includes the transformer engine with an updated NVL link that's twice as fast, significantly improving the speed at which the system can handle data and calculations. This is crucial for systems that rely on multiple GPUs needing quick data updates to remain efficient. This enhancement is not just a minor update, it is considered a groundbreaking change that significantly boosts the system's overall efficiency and capability. Yet this ongoing rush for the latest technology raises serious questions about its sustainability and the environmental impact of throwing away old but still usable technology. The increasing amount of electronic waste is damaging to the environment. Moreover, as technology becomes more complex, it requires constant updates and compatibility checks, which can be overwhelming and costly for users constantly told their systems are outdated. As these technological marvels evolve, they reshape how society functions, pushing the limits of what machines are capable of. However, this constant evolution also requires us to critically assess whether these innovations truly benefit us or just feed an endless desire for the latest and greatest in technology. Are the new features of FP6 and FP4 genuinely transformative, or are they just part of a bigger show put on to attract investors and control the market? It's essential to consider whether these technological advancements truly meet the practical needs of the users they aim to help. Let's discuss the new technology everyone is talking about called FP6. It's popular because it can hold much more data than previous versions. However, despite this additional storage, it doesn't operate any faster, which is quite a disappointment. Then there's another technology, FP4, which is said to transfer data twice as fast as its predecessors, enabling computers to process information and make decisions more quickly. The creators of these technologies are pleased, claiming they will use less electricity, reduce internet congestion, and increase overall efficiency. They describe this as a significant step forward in technology. Let's see if new tech really changes our daily lives or is just more gadgets. The illusion of technological advancement. Do these new tech tools really change our everyday digital life, or are they just more things in our tech collection? One might wonder if these upgrades really help the average person. While tech fans and big companies may like these new features, most of us might not see a big change in how we use our computers daily. Amid all the hype about how these new ideas will change the industry, it's worth asking if all this excitement is just a way to sell a new, appealing product. While the tech pros talk about changing the industry and next-gen tech, the rest of us might just watch from the side, trying to figure out if the new hype is about something truly new or just an old idea with a new look. Let's look closely at what Nvidia is promoting now, starting with their Blackwell AI supercomputer. They say it's a big step forward, claiming it works 5 times better than its previous model, Hopper. But in the tech world, the chase for bigger and more powerful never stops. Nvidia didn't just launch one new product, they also brought out another, the NVLink switch, with 50 billion transistors, matching Hopper in size. This device, with 4 NVL links, each able to move an impressive 1.8 terabytes of data per second, lets all GPUs in a system talk at full capacity at once, pushing tech limits even higher. Moving from small tech tweaks to major changes in system design, these updates are key in running large systems like the DGX. Just 6 years ago, Nvidia launched the first DGX-1 to OpenAI. Back then, it was a strong device with 170 teraflops of computing power. Fast forward to today, and this number has jumped to a huge 720 petaflops, almost reaching an exaflop of power. This means the system can do a quintillion calculations per second, all in one rack, turning what was once just a strong computer into a giant supercomputer in a small size. In the tech world, announcements often come with big numbers and complex terms, meant to impress those who might not understand the details. This show of new tech usually includes a boost in power numbers, a common thing at tech launches. To outsiders, these increases seem groundbreaking, yet they follow a familiar pattern, painting each update as more transformative than it might really be. As Nvidia introduces its latest tech updates, it's important to think about what they really mean. For most people, these tech leaps might just be another set of numbers in a news update, barely touching their daily lives. These advancements are more valuable to tech lovers and big businesses, but they make us wonder if they really improve technology for everyone or just add to the race for the most impressive device. This constant drive to pack more power into smaller devices isn't just about making computers faster or smarter. It's also about keeping customers interested. Each new processor or system isn't just a tech piece. It's part of a bigger story that keeps the tech world excited and keeps everyone else watching. These product launches are more than updates. They are big events designed to keep people excited and engaged. However, behind the scenes, there are big downsides. There's a serious environmental impact from making new tech that soon becomes old and turns into waste. Economically, it forces consumers to keep buying the newest, often pricey tech that may soon be outdated by the next release. Also, while these technologies are sold as groundbreaking, the real need for such advanced computing power is questionable for average users or even most businesses. At the heart of Nvidia's latest tech is the DGX NVLink spine, an extremely fast network capable of handling 130 terabytes of data every second. This is more data than the entire internet handles now, theoretically letting the system send info to every person on Earth instantly. The setup includes 5,000 NVLink cables, which, if laid out end-to-end, would stretch over 2 miles long. By choosing NVLink instead of optical tech, Nvidia avoided using an extra 20,000 watts of power that would have been needed for more gear, thus saving enough energy to power several homes at once. These energy savings are vital, especially considering the system's cooling mechanism. It uses water at a normal room temperature of 25 degrees Celsius and heats it to 45 degrees C to keep the system at an ideal temperature without using too much power. The manufacturing scale of these devices has also grown a lot. Modern devices are made up to 600,000 components, a massive increase from the 35,000 parts used in older models. This scale not only shows Nvidia's ability to produce in high volumes, but also highlights the complex and resource-heavy nature of current tech development. Now, let's look at how Nvidia's tech works in real life. The energy efficiency evolution in AI. Weighing 3,000 pounds and made up of 600,000 parts, these GPUs are considerably heavy but still much lighter than an elephant. Observing these GPUs operate is quite impressive. For example, previously, training an advanced AI model with 1.8 trillion parameters took about 3 to 5 months using 25,000 older Ampere GPUs. However, using the newer Hopper GPUs, this number drastically decreases to only 8,000 GPUs, consuming 15 megawatts of power and completing the task in just 90 days. Technological advancements continuously redefine the boundaries of what was once considered possible. The latest improvements in Hopper GPUs have not only increased computing capabilities, but have also significantly boosted energy efficiency. However, it is the introduction of the newest GPUs by Blackwell that has truly shifted the landscape. These innovative GPUs accomplish the same tasks within the same 90-day period as their predecessors, but do so with only 2,000 units instead of more. Additionally, they drastically reduce the energy consumption from 15 megawatts to merely 4 megawatts. This big improvement means a lot more than just saving energy. It marks a big change in how we try to do more with less, setting new standards for using resources efficiently. These changes go beyond just making things better technically. They can change the way we think about and make new technologies in the future, focusing more on saving money and helping the environment. Blackwell's new GPUs are a big step forward, pushing for tougher standards on how much energy is used. The whole industry is watching this move, ready for a time when technology not only costs less to run, but also helps save resources. As the tech world gets ready for this big release, the possible effects on the technology sector are huge. This change could totally redo how tech companies operate. Everyone is looking at this big tech breakthrough that could change how we handle and use data in many areas like healthcare and media. The ability to quickly and easily manage lots of data could change what we think is possible with technology. However, we should hold back our excitement a bit. The idea of physical AI, or the next step in robotics, isn't really new. It's mostly about putting a lot of data into a fancy machine to make it seem smart. Until now, the big talk about artificial intelligence has been about loading tons of data into systems like DGX. This data is squeezed down, turning trillions of data points into billions of parameters that try to mimic human actions through AI systems. The current talk is about this being a key time for robotics, like when ChatGPT was first introduced. There's been a quiet, ongoing effort to make robots that can handle tasks on their own from start to finish. The teams working on these technologies have made systems like DGX for general AI tasks and AGX for robots that work by themselves. The big question is whether this technology will really change the game or if it's just another hyped-up tool among many tech gadgets. As the tech community watches this launch closely, it's not just a test of new technology, but a key moment that could change the tech landscape for many people, not just experts in Silicon Valley. For those who know a lot about this, the Jetson chip is often talked about as the best technology for managing AI in moving vehicles. It's a key part that fits into the larger DGX system where the AI is trained. The Jetson acts as the main controller for automated vehicles, helping them work well in the real world. But the setup is more complicated than it seems. There's another layer of technology needed that makes things even harder. This extra computer has a huge job. It has to create a full digital version of the world. Basically, this is a fake world where robots practice and learn before facing real situations. They call this virtual place the Omniverse, managed by a special system called OVX. The reliance on technology doesn't end there. The whole setup heavily depends on the Azure cloud. This means that the robot's ability to work is tied to their constant connection to the cloud. Every part of this system is connected, creating a complex web of technological dependence. With these advances, what are the risks and challenges? The balancing act of cutting-edge automation. However, beneath this impressive technological display lurks a potential vulnerability. The dependence on a continuous cloud connection and multiple layers of specialized technology renders the entire system susceptible to failures. A failure in one critical component, especially the cloud connection, could jeopardize the entire operation. While the developments may seem like a groundbreaking step towards autonomous robotic technology, they also represent a setup fraught with risks. The intricate layers of technology may appear robust, yet they could prove to be the system's Achilles' heel, vulnerable to disruptions that could unravel this complex network. As technology advances, it raises questions about the stability and sustainability of such a heavily interdependent system. Is the groundwork being laid for a future of technological resilience, or is it merely setting the stage for potential technological setbacks? Zooming out to view the broader landscape, each component of this robotic setup, including DGX, Jetson, and Omniverse, demands substantial resources. The discussion isn't limited to the immense amount of energy these machines consume, but extends to their high costs of acquisition and maintenance. Picture this as a complex machine where each part is crucial. Even a minor issue with just one component can cause the whole system to malfunction. It's akin to setting up a delicate arrangement of dominoes. A slight error could cause everything to tumble down, highlighting the precarious balance of this technological venture. Additionally, these systems depend heavily on a constant internet connection. This connection is vital because it keeps data moving and allows these machines to operate smoothly. However, this constant connectivity comes with its own set of risks. Every piece of information that travels over the internet can potentially be stolen or lost. Imagine what would happen if the internet suddenly went down, or if a cyber attack broke through the system's defenses. Operations could stop abruptly, or even worse, private and important information could be stolen. The fascination with these new technologies often overshadows the practical challenges they bring. While the inventors of these machines talk about how they are transforming the future, the everyday reality involves a lot of problem solving. These high-tech devices must not only function well in controlled tests, but must also perform reliably in real-world conditions, which are often far from perfect. They need to prove that they can handle everyday tasks consistently without breaking down. Maintaining such sophisticated technology requires a lot of effort and attention. Each part of the system, from software to hardware, needs regular checks to ensure everything is working as it should. Any interruption in service, even a minor one, can lead to significant problems, disrupting not just individual tasks, but potentially entire operations. This can be stressful and costly, demanding not only time to fix, but also money for repairs and updates. The people creating these technologies are keen to show off their newest innovation with something they call the Omniverse. They have put together a demonstration that seems almost too exaggerated to take seriously, offering a look at what they claim is the near future. This demonstration is set in a place they grandly refer to as a robotics building, which is really just a fancier term for a warehouse. Inside this warehouse, they introduce what they call autonomous systems. It gets a bit strange here. They categorize both humans and forklifts as autonomous systems. In their vision for the future, humans are compared to machines, each programmed to function independently without needing direct human control. A modern warehouse where technology meets practicality, humans and forklifts operate in seamless harmony, all under the watchful guidance of the warehouse itself, which doubles as a central controller. This warehouse is no ordinary structure. It's said to be able to communicate with those within its walls, managing its operations flawlessly in real time. As one delves deeper into this realm of advanced robotics, it becomes evident how deeply technology is woven into everyday use. The integration of such technology is revolutionizing the interactions between people and machines, marking a new era where manual and mechanical operations merge effortlessly. This unfolding narrative showcases the evolving landscape where human ingenuity and robotic precision coalesce, ensuring safety and efficiency in a meticulously orchestrated environment. Regarding the robots that were presented earlier, each is designed to operate on its own, equipped with a specialized set of software designed for robots. The grand aim here is to convert every moving object into a robotic form. They argue this will increase safety and make operations more convenient, especially in large industries like automobile manufacturing. This technology is expected to first appear in Mercedes cars next year and shortly afterwards in Jaguar Land Rover vehicles. The most recent news is that BYD, which they claim is the biggest manufacturer of electric vehicles in the world, has decided to use this advanced technology, known as Thor. Thor is tailored to control what they describe as transformer engines and is set to become the controlling mind for the next generation of autonomous vehicles. Thus, this futuristic path continues, filled with promises of transforming our interactions with technology. Virtual reality's role in shaping tomorrow's robots. Interest in humanoid robots is growing as developers make more robots that look and act like humans. People who like this idea say it's good because robots that move like us might be easier to make. They want to use lots of data, like videos and virtual reality, to teach these robots how humans move and act. These high-tech robots are getting better in a digital place called the Isaac Reinforcement Factor Learning Gym. Here, they learn and get better at everyday tasks. A supercomputer named Thor, first made for self-driving cars, now helps run these humanoid robots. Thor does the tough math needed by transformer engines, which work with big data streams fast. People talk a lot about how this tech could smoothly blend robots into our everyday lives. But it's good to be careful and think if this tech is really ready or if tech companies are just making big claims. As we use more technology, the rise of humanoid robots makes us think more about what it means for jobs, privacy, and safety. These robots, looking and acting more human, could change a lot in daily life. From cars to warehouses, it's important to think about these big changes. The promise of new tech often makes us forget to really look at how we use it and the problems it might cause. Taking a close look at humanoid robots helps us understand not just what they can do, but also the social, economic, and ethical issues they bring. Thinking about this helps make sure robot development fits with what society needs. We should ask why we're moving towards more robots. Is it really to make life better, or do tech companies just want to get people excited? As robots start doing more human-like jobs, it's key to see if this really solves problems or just lets tech companies show off new stuff. Nvidia is leading this mix of computer graphics, physics, and AI. They have a project called General Robotics 003 with robots named Orange and Green. These robots use Jetson Robotics computers and are part of Disney's BDX robot team. At a big event, there was a rush at the end, and the robots seemed a bit off. We hear about a new era with $1 trillion going into updating data centers. At the heart of this is a generative AI called Blackwell with 1 trillion parameters. It uses new processors and switches to move data fast and is seen as a big step in GPU tech. The future might see robotics in many parts of our lives, from self-driving cars to robotic arms in warehouses. This push towards machines doing more might mean less physical work for people. While this sounds efficient, it's worth wondering if this is really about better lives or tech leaders making money. More and more, big places for robots are being built. They all rely on a digital setup called the Omniverse, seen as the future operating system for robotics. It aims to blend digital and mechanical parts smoothly. As technology keeps advancing, we think about how to make work better and industries more efficient. But this move to more robots brings questions. How will humans fit into this new world? Can we trust these complex systems to work well? What happens if there are big tech failures? Despite worries, the push for more advanced automated systems doesn't stop. Companies like Nvidia keep pushing AI and robotics forward. They see a future where machines do most of the tough and risky work, making things faster and safer. Is this shift towards a machine-dominated world truly enhancing human life, or are we creating more problems than we solve? Leave comments and subscribe for more thought-provoking content.